Quick video here on electrical resistance. So resistance is just that, but just to be clear, what is it resisting? The French resistance, it's the resistance to current. So electrical resistance is measured in something called an ohm, and that's represented by the Greek letter omega, which is this. So you may be like, what the heck? Whenever we see the symbol, we're going to read it as ohm. So we get the word ohm, by the way, by this gentleman right here, Georg Simon Ohm, lived from 1789 to 1854, so about the same time as André Marie Ampere. He was a German physicist and 12 feet tall. So don't get resistance confused with resistor. These devices are resistors, and their job is to create resistance in a circuit. They're just little pieces of ceramic, kind of like what your coffee cup is made out of. And their job is to make it harder to get through a circuit. Why would you do that? Well, maybe a battery that you have is providing too much current for a device, and you want to cut that current down by adding resistance. And resistor's job is to add resistance. So let's imagine this. If we have a graph of voltage versus current. If we connect more and more voltage to a circuit, we will pump more and more current through it. That kind of makes sense. The more push we have, the more charge we will cause to flow through per every second there. So this graph right here would represent, the slope of it would represent the volts over the amps here. So that is what we call resistance. So the resistance is basically how many volts it takes to get a certain amount of amps. So you can think of an ohm as the volts per amp, and that's not super critical. You don't have to remember that in detail, but that's kind of where we can think of a ohm coming from. So think about it like this. If you have an 8 ohm resistor, what you're basically saying is it would take 8 volts to get 1 amp to flow through it. If you have a 16 ohm resistor, it would take 16 volts to get 1 amp to flow through it. So the higher the resistance, the more voltage it will take to get a certain amount of current here. So we can think of the slope like this. The resistance is the voltage over the current. This right here is known as Ohm's law, and we're going to use this to do some problems here. The more you can think about it like this. Here's volt trying to push poor amp through the circuit here, and here's ohm trying to stop it. So this is the exact same equation I'm going to put up here in a second as I just showed you, just rearranged. This is the more common way we write it. I equals V over R. More voltage gives you more current. More resistance, since you're dividing by it, would give you less current there. The way you often see it in books even is actually this, so you don't have to write a division bar. But all three of these are the exact same equation. They're just written to solve for different things. So now we have a very simple little equation that we can use to solve for current if we know the voltage and resistance, to solve for the voltage if we know the current and resistance, and to solve for the resistance if we know the voltage and the current there. And you're about to use some do some problems involving this quick little equation right here. One more thing about resistance is the type of wire can affect the resistance. So a longer wire compared to a shorter wire will give you more resistance. A thinner wire compared to a thicker wire will give you more resistance. It's like a thinner hallway or a longer hallway, and students are trying to pass through it there. Different materials can affect the resistance. So iron, even though it's a good conductor, is not as good as copper. And so that's another thing that will affect the amount of resistance. And then finally, temperature can affect it. So a higher temperature will cause the resistance to go up in a given wire there. So here is how you could calculate the resistance of a given wire. This stands for length. So more length, more resistance. This stands for the area of the wire. So the bigger the area, the thicker the wire is, since we're dividing it by it, the less resistance. And then this is called the resistivity. We're not really going to get into it, but it's what the wire is made out of. So iron, again, would have a higher resistivity than copper. And so basically, I just want you to know this. Longer wires, more resistance. Thicker wires, less resistance. And that is the end of the resistivity.